Okay, so we are going to take a look at section 6.2, which is on page 7 in your pocket. And this whole section is about radical operations, how to add radicals and subtract radicals and multiply and divide and all that good stuff. We are on page 7 in the notes. Hopefully we're ready to go. Perfect. Radical operations. We're first going to deal with adding and subtracting. There's a whole bunch of roots down here that we need to try to add or subtract. To add or subtract radicals, all we need to do is simplify and then combine like terms. To add or subtract radicals, we are going to simplify and then combine like terms. And I think I need to also mention what like terms are going to be as far as roots are concerned. Our rule is going to be to simplify and then combine like terms. For roots to be like terms, they must be the same type of root. A square root and a cube root aren't going to be like terms. And they have to have the same stuff underneath. They must be the same type of root with the same stuff, numbers and variables, underneath. To add or subtract radicals, we're going to simplify and then just combine like terms. What are like terms as far as these roots are concerned? Well, it's got to be the same type of root. Can only combine a square root with a square root. And they have to have the same stuff underneath the root. And I'm saying stuff because I mean numbers and variables, everything kind of mixed together. So, first problem. I want to do the square root of 7 plus 2 root 7, which is like saying 1 root 7 plus 2 root 7. You got one of those things and two of those things, so how many of those root 7s do you have altogether? 3. That's all we're doing here. You are not touching the root. You're not changing what's under the root. 1 root 7 plus 2 root 7 gives us 3 of those root 7s. That's it. I bet you can do letter B. Try letter B. Hands. Elias. Exactly. 5 of these things minus 11 of those things. You got negative 6 of those things. Don't get rid of the root. It still needs to be there, like Elias said. Negative 6 times the cube root of 6. Not bad yet? How about the next one? 3 root 2 plus 5 root 7. Why are you just sitting there? Oh, are they like terms? They're not like terms. We can still add them, though. You know how we're going to add them? Our answer to this problem is 3 root 2 plus 5 root 7. The answer is still going to be a sum. That's the best we can do. If they're not like terms, you don't say not possible. You just give the two different terms left in the answer. However, that's not the case in letter D. You can combine these. Why? Jordan. I haven't given you any problems yet where there's been any simplifying that we could do, but here, yeah, we can do that. Root 18, well, thankfully, that's just a square root. How are you going to break that down? Square root of what times what? Oh, you can do 18. You can do 18 in your head. And we're doing square roots here. Anyone? Maya? 9 and 2. Well, and the point is that becomes 3 root 2. plus 4 root 2. And now, yeah, you can go further. So the answer is 7 root 2. Before doing anything, you really need to go and you need to simplify your two roots. If they end up having the same stuff under the root, you're good. You can go and combine them. Do not touch the stuff under the root, though. A root 2 gives you a root 2 in the answer. Don't make it root 4 or anything like that. And if not, we'll just leave it like letter C. But you can't say that until you've tried to simplify things. I would like to see what you can do with letter E. They are not square roots. They're cube roots. So see what you can do. Jordan, if you want to take out your Chromebook, you're welcome to do that now, but please go on a calculator for Wednesday. Say that again? So that was the stuff we did before the break, so you will need to get some notes on that. Oh, that's not what I wanted it to be. Well, whatever. What's inside 384? Who found something? Perfect cube inside there. I think I'm just going to wait and give you more time then. Keep going. Aryin, what did you do with the 384? 64 times 6, that'll work. You could have done 8 as well, but 64 will get you there quicker. So what does that become when you simplify it? Good. 4 cube root of 6. Okay. Ashley, were you able to do anything with 108? I think I know why you erased it, and I think you're fine with that. PJ, what do you do? 27 and 4, does that sound familiar, Ashley? Yeah, and PJ, what does that give you? 3 times the cube root of 4, right? And now what? Now what do we do? Jordan, you draw a box around it and you say you're done because they're not like terms. If they were, you'd go further and you'd combine. I'm almost certain that at least one of the homework problems, they won't be like terms. Don't let that fool you. Just do your simplifying, circle the final thing, and you're good. That is what I have to say about adding and subtracting. Any issues here?
If they are like terms at the end,
Yep.
you'll be able to figure that out soon, right?
Well, sure. We'd have 4 times the cube root of 6 minus 3 times the cube root of 6 or something like that. We'd have the exact same stuff under the roots. And by the time you're simplified, it will just show up there like that. And if not, then they're not like terms. Anything else? Okay, so the multiplying gets a little bit more involved. Multiplying radicals. First of all, for right now, we're only going to look at multiplying roots of the same type. So only a square root times a square root, a fourth root times a fourth root. We will learn how to multiply a square root times a cube root, but not till like Friday, I think. So first of all, what I'm about to show you only works if the roots are the same type. I think I'm just going to give you the process, then we'll look at an example rather than the other way around. First thing we're going to do, if there's stuff outside the root, we'll multiply the stuff outside together, and we'll put the product on the outside. Step number 1, multiply the stuff outside the roots. And put the product on the outside. There's stuff outside the roots. We'll multiply those things. We'll put our answer, our product, on the outside of the root.
What did you say after product?
So multiply the stuff outside the roots and put the product on the outside. I'm also going to go and I'm going to multiply the inside stuff together. Multiply the insides together and put the product on the inside. Multiply the stuff inside the roots. And put the product on the inside. There is one more step. I'm going to be left with something inside my root, so simplify. Anyone still writing? Turn the page. Okay, so letter A, I want to multiply 2 root 3 by 4 root 2. My rule says multiply the outsides, put on the outside. Multiply the insides, put on the inside. So on the outside, I'm going to multiply 2 times 4, and I'm going to get 8. Any help, please? Pull up that mask. Thank you. On the inside, I'm going to multiply 3 times 2, and I'm going to get 6. And 2 root 3 times 4 root 2 is 8 root 6. Is there any more I can do here? No perfect squares inside 6? So I'm done. Go do the next one. Can you get 20 root 400? Are we done? Nihal. Yeah, what is the square root of 400? It's actually a good number. It's just 20. I don't even really need to do the breaking down because it is already a perfect square. Your answer? 400. And if it wasn't like that, I'd have to break things down and be left with something under my root, but that's not the case over here. Do you see how that worked? Okay, letter C. I want to do the first step together, and then I think you're going to go. First thing I need to do is multiply. I'm going to multiply the outsides together. What is z times x cubed? And don't overthink. Zx, sure. And you know what? I'm just going to put the x first because then it's in alphabetical order. I have no reason for that. I'm just going to do it like that. Inside, go multiply your 140 times 28. Hello? That's okay. Yes, absolutely. I'll send her down. Yep, bye. Meredith, can you check in with the office very, very quickly right now? Inside the root, what's 140 times 28? 3,920, good. Multiply the variables, I think that gives us x, y squared, z cubed. The rest of this problem is now just a simplify the root type of thing. That's kind of where I mentioned a moment ago. Today is going to be a lot of more practice with the simplifying, because once we do the multiplying, which is not the hard part, now we just have to break things down. Take a few moments, work on breaking that down. Show me the perfect squares inside your 3,920. Break down the variables appropriately. Let's see what we can do with this one. As always, yes, I will be looking for all the breaking down stuff along with the work. Do we have a calculator? Get out your Chromebook for today, but we need to run a calculator. Do we have a Chromebook? Oliver, can you tell me what you did with the 3,920?
Multiply it by 784.
That will work. I wasn't finding anything that high. I just did 16, and then later I did 49. But yeah, that will work, 784. As far as the variables, x you can't do anything with. Y squared is already good. Z to the third is z squared times z. Well, Oliver, since you did 784, what is the square root of 784? One more time? 28, yes. And again, I didn't see something like that. I just did 16, and then later I did 49. But yeah, that will get you there a little quicker. X to the third z. I'm also going to move out of y. I'm going to move out of z. Inside my root, I have a 5xz. So I think 28 x to the third y z squared, square root of 5x z, I think. Questions or issues? PJ, you look like you've got a question. Is the issue with the numbers? With the z. What did I do? So I said z to the third was z squared times z. I did the square root of that and got a z, but I already had a z out front from the straight multiplication in the beginning. So then z times z will give me a z squared. Anything else? That's what's left inside. Okay. I don't feel like we have to do both d and e. D is a cube root, e is an eighth root. How about we go do letter e, because if we can do an eighth root, we can probably deal with anything here. Plus, the eighth roots are kind of nice because they get simplified fairly quickly, I think. Go do your first step of just multiplying, and then stop, just to make sure that's good, and then I'll send you off to go do your simplifying. Let's see, I think 12 x to the 13th. Sign out an e-hall pass. 12 x to the 13th, y to the 7th, I think, on the outside. Maya, do you have the inside? Give me 1 second, 1,280. Okay, x to the good, y to the good. Now this just becomes a simplifying problem. So take a few moments, go simplify that eighth root. And let's see what happens with these. Go quickly. Priyanka, what did you do with 1,280? Yeah, the nice thing about the high roots is usually like the first or second thing you try is probably going to work. And yeah, that was probably the first thing you tried. Times 5. Hunter, how did you break down the x to the 27th? That will work. And PJ, let's pull up that mask, please. And also tell me about y to the 37th, PJ. Y to the 32. Y to the 5th. Good. So that means I can move out front. Let's see. What is the 8th root of 256, Priyanka? Because you got that number. Wait, say that again? Not 32. What is, Jackson? I think it's just 2. I'm not sure. Should just be 2 there. 8th root of 256 should be 2. 8th root of x to the 24th should be x to the 3rd. 8th root of y to the 32 should be y to the 4th. We're left inside our root with a 5 and x to the 3rd or y to the 5th. I'll go and multiply all that outside stuff. If you want to do that in one step rather than show how each piece is getting moved out, that's okay. But I think it might be better to do the work in the middle so we're not making little mistakes that you're not going to catch if you're not kind of showing the breaking down in the middle. But this will be 24, x to the 16th, y to the 11th, and inside we've got a 5, an x to the 3rd, and a y to the 5th. Multiply the outsides, and then just simplifying. What your quiz on Wednesday will be is I'll just give you something like this and ask you to go do your simplifying. I'll give you the thing already set. You just simplify, no multiplying. Okay, letter F. What's your problem? You should have a problem with letter F. What's wrong, Jordan? I told you we can only multiply roots if they're the same type. Well, actually, we can still do this problem, though. Jackson, what's going to happen?
Simplify 27 by
What is the cube root of 27? Oh, okay. And what's the what's the 5th root of 32? 2. Even though you can't multiply a cube root times a 5th root, you certainly can multiply these. And of course, you're going to tell me, I was hoping you weren't going to say 5. Good. Yes, it is 6. That's all we're going to do. If I give you 2 different types of roots right now, they'd better end up being nice numbers. Otherwise, you'd have to say, well, just the cube root times the 5th root and leave it like that. Friday, we'll see how to do this for real. Okay, next. Does letter G make you think of anything? Oliver? Foil. That's what the bottom of this is all about. Foiling stuff over here with roots. Anytime we have a sum or difference that we're multiplying, there's going to be some foiling involved. So let's go and let's do this. 2 times 2, easy. 4, thank you. 2 times negative root 7. Yeah, the 2 is outside, the root 7's inside, you can't do anything with them, so we'll just say minus 2 root 7. Then I think I need to do root 7 times 2. Which of course is... No. Plus 2 root 7. Which, yeah, may give you something nice in this problem in general. No, that won't be the case. Now, here's the part where people usually mess up. Root 7 times root 7 is root what? Not 14. 49. Multiply those things. Far too often people tell me this is minus root 7 because they're like terms. No, that's not how that works. We need to actually multiply the things inside. Now, well, that's really nice in the middle. Those things just cancel. That's gone, that's gone. That's not usually going to happen. Usually there'll be like terms we'll have to combine.
I think that's where I got the 0.
Sure. What's the end? Jordan? No, not 7i. Just 7. Because it's not square root of negative 49. It's just square root of 49 as a number. We're going to get 4 minus 7 Actually, I have no roots at all in my answer. I just have negative 3. Now, usually there will be roots left inside there, but here, no, there wasn't anything. Can you try the foiling for h and then stop? Don't do any simplifying yet. See if you can do your 4 moles. This is definitely a tougher one. Jackson, you look like...
Oh, no, I was trying to figure out where you got the 4 from, and then I realized that the negative 2 root 7 and the positive 2 root 7 cancel each other out.
Yes, but the 4 is not coming from that. The 4 is coming from...
Yeah, I know.
Perfect. Good. Try the foiling and then stop before you start simplifying things, because there will be a lot of simplifying work here. And remember our rule that outsides, you multiply them, put them on the outside. Insides, you multiply them, keep them on the inside. So I think, well, the first one's easy. 3 times 1, that's just 3. What is 3 times 4 root 6? What is it? Jordan? 3 was on the outside, technically, so that counts as an outside number. 3 times 4 is 12, and we're going to get 12 root 6. Okay. 2 root 6 times 1. Don't think super hard. 2 root 6. 2 root 6 times 4 root 6. PJ. 8 root 36. Don't tell me 8 root 6. It's 8 root 36. I want to see if you can finish this now. There is some simplifying you can do. There will be some like terms you can combine. See what happens. Ashley, what do you do with the middle 2 pieces? They're like terms, so we can combine them. Jose, what about that 8 root 36? What can you do with that?
So, for 36, so you can just say, you have to get outside, put 8 times 6.
You're just going to get 48 from that piece. 3 plus 14 root 6 plus 48. Your answer here is going to be 51 plus 14 root 6.
Why are we multiplying the 6?
Because, well, this was a multiplication problem. H times the square root of 36, squared, so it stays multiplication. Anything there? I think as far as foiling goes, I is about as tough as they're going to get. See what you can do. There's nothing really new in that one. But see how far you can get with letter I. Remember our rule, if it's on the outside, keep it on the outside, inside, keep it on the inside. Keep the outsides on the outside, keep the insides on the inside. How about 6 root 25 for that first piece? 2 root 5 times 3 root 5, 6 root 25. Do the other three, see if you can simplify, combine like terms. It's kind of nice by the time it's done, I guess. I'm getting 8 root 25 minus, no, 6 root 25 minus 8 root 15 plus 9 root 15 minus 12 root 9 for my first line of following.
When we're adding, the insides are the same. The only reason like
Say that again?
so when we're adding,
Yep.
so the numbers that are inside.
You don't change them. You keep them because that's what makes them like terms.
Okay. And if it's like 2 and 2 on the outside, you can just like subtract or add them.
Right, exactly. So I think this is 6 times 5. I think we can combine those and get plus 1 root 15. I think at the end minus 12 times 3, so 30 plus root 15 minus 36. Maybe negative 6 plus root 15 for an answer here. Meredith.
Why is it not minus root 15?
Because negative 8 plus 9 will give you a positive 1 over there.
Oh, okay.
Negative 8 plus 9, that's positive 1. And of course, that's not going to go flying through the air. Nihal, do you see what I'm talking about? Questions? We can do division. Or if I give you some time and let you start the homework, will you actually start the homework? That means no like flying airplanes or other things like that. We're actually going to start stuff. Homework is page 26, 1 to 13 odd. Meredith?
Can you show me
Not D, but I can show you C. You skip D. So a few things. Next time we're going to do a quiz on just the simplifying 1 cube root and 1 or 2 other types of roots. Make sure you have a calculator, and if you show up to school without one, find someone not in math during A block and borrow their calculator.
What do you say for the numbers?
So homework, page 26, 1 through 13 odd. Make sure you show me the breaking down work and all that stuff, like usual. Not that much, but some of them take a while to break down, which is why I only gave you 6. And I think that's what I have to say. Let me shut off this.